All right, so I got another question from Poisson Distribution. So this says the demand for fans follows a Poisson distribution with a mean of 3.2 per week, and in part A, they want us to find the probability that the demand is exactly 2 weeks. So this will be, so I can define this first. X is Poisson with 3.2 for a week. So probability of X exactly 2, which is e to the power of minus 3.2 into 3.2 to the power of 2 over 2 factorial. And I need to tell you one more thing. For Poisson distributions, if lambda value, the mean, is less than 10 and has an integer value, we can always use the Poisson tables. It also has the cumulative probabilities, but in this case 3.2 is not an integer, so we will have to do it manually, even though uh, Poisson tables are available for lambda less than 10 values. So this will simplify and give you e to the power of minus 3.2 into 3.2 to the power of 2 over 2 factorial, which is 0.209, correct to 3SF. Part B, it says the shopkeeper has 4 fans in his shop at the beginning of a week, and find the problem that this will not be enough to satisfy the demand of fans in that week. So if you go run out of stock in this particular week, definitely the demand should exceed 4 fans. If the demand was less than 4 fans, you can still meet the demand. So the probability requirement here should be x greater than or equal to 5. That is same as 1 minus x less than or equal to 4. As I explained you already, I cannot use the cumulative Poisson table here because my value of 3.2 is not available. It's not an integer value, so I may have to do it randomly or manually, which requires a lot of simplification. So this goes from e to the power of minus 3.2 to the power of 0 over 0 factorial plus e minus 3.2 into 3.2 to the power of 1 over 1 factorial e to the power of minus 3.2 into 3.2 over 2 over 2 factorial e 3.2 into 3.2 cube over 3 factorial plus e 3.2 into 3.2 to the power of 4 over 4 factorial. So there are 5 scenarios when you say probability of x less than or equal to 4. It could be 0 fans were sold or asked for it, otherwise 1 fan, 2 fans, 3 fans, or 4 fans. So any of these scenarios will still be taken as or considered as the demand is met. So if you are unable to meet the demand, it should be sub 1 minus the total probability minus subtraction of these 5. So to simplify this easily, I might take e minus 3.2 out. Now I got 1 here because 3.2 to the power of 0 over 0 factorial is 1 plus 3.2 plus 3.2 square over 2 plus 3.2 cube over 6 plus 3.2 to the power of 4 over 24. Let me also explain you an easy way to enter this into cal. What I do is normally I apply 3.2, I enter it into my cal and press equal sign first, and now it's e to the power of minus answer, then brackets. I open up the brackets and I add 1 plus answer square over 2 plus answer cube over 6 plus answer to the power of 4 over 24, and then I close brackets. So this will give me the probability of this whole series, and then I subtract it from 1 and I get an answer which is 0.219, correct to 3 signal figures. So my part C, given insert that n fans in this, that he has n fans in his shop beginning of the week, and then they want us to use the trial and error method to find the least value of n for which probability of his not being able to satisfy the demand for fans in that week is less than 0.05. So when you had 4 fans, you should understand the demand for not being able to meet, it should be x greater than or equal to 5. So similarly over here, x greater than or equal to n plus 1. So this should be the condition where he is unable to meet the demand. So this is 1 minus probability of x less than or equal to n, and over here that should be less than, so this probability should be less than 0 0.05. So now we got this condition, x is greater than or equal to n should be exceeding 0 0.95. It should exceed this should be x less than or equal to n fans, and that should be exceeding 0 0.95. So when n is equal to 4, we already know probability of x less than or equal to 4 is equal to 0 0.781. So this is less than 0.95, so this should not work. So the next option is we need to go for n equals 5. So this is x less than or equal to 5. Let's check this probability up. All we need to do is, we already have this part, we just keep adding the next term of the series so that we get the probability of that. So this one goes up here, and then we got e to the power of minus 3.2 into 3.2 to the power of 5 over 5 factorial. So that's the next value, and that becomes 0 0.895. Still it is not good enough, so we reject that answer as well. And next I go into x less than or equals 6, and this one also will have the same, e to the power of minus 3.2 into 3.2 to the power of 3.2 to the power of 6 over 6 factorial. So this should give us a value 0 0.956, 0 0.955 to be more accurate, and this is more than 0.95. So this is the first least value, so therefore we can conclude that n is equal to 6. Yeah, hope you understood.